Hello and welcome to your final exam review for the Python programming section of the test. So as I already kind of mentioned, the main focus is going to be on pictures and sounds. You do not need to be concerned with the animation stuff that we've been doing at the very end here. All right, the questions on the test will focus on pictures. They'll focus on sound manipulations. All right, so let's take a look at a couple of these and make sure that we're comfortable on how to do these. So number one says, write the function white corner pick that turns the bottom right corner of a pick to white. Hints, use get width, get height, get pixel, set color. All right. So notice that this says we are turning a picture to white. We're not creating a new picture. So this isn't going to return anything. It's just going to modify the picture that it receives. All right. So we'll start with our function def white corner. We're going to go through pick. That's the picture that's being sent in. Now, because we don't want to modify the entire picture, we only want to modify part of the picture, we're going to have to set up our nested loops. We can't just use the get pixels because that's for going through the entire picture. We only want to go through part of the picture. So we'll do our for x in range. And here's kind of the whole point of this question is if we want to get to the bottom right, all right, what is that really going to look like? Well, we're going to need to get the width of the pick, but then kind of go back 100 pixels. So we'll subtract 100 from that, and then we'll finish at the width. So get width of pick, and then I've got my colon there at the very end. All right, so I'm basically going to the end of the picture and then sliding back 100 pixels. And then I'm going to do the same exact thing for the y. So for y in range, I'm going to get the height of my pick, and then I'm going to go up 100. So I'm still subtracting, because remember 0, 0 is the top left corner. And then I'm going to go to the height so that I go to the very bottom. And then again, I'll close it off and put in my colons. All right, so that will just focus me on that bottom right corner of 100 by 100. Now, if I want to turn it white, I have to remember that these loops are just generating numbers. They're generating basically coordinates. I have to use those coordinates to retrieve the pixel. So I might say something like, okay, px equals get pixel. And then I specify where I'm getting it from. I'm getting it from pick. And specifically, I'm getting it at the XY coordinates that are being generated by my loop. Now that I've retrieved the pixel, I can actually set its color. Now I could do set red, set green, set blue, and set them each to 255, or I can just use set color of px to white. Right. And again, I don't need any sort of return because I'm not making a new picture here. I'm just modifying the picture that was sent. I'm modifying this pick object that was sent into the function. Okay. So that's an example of something that you might have to write. Number 2, examine the function increase volume below that increases the volume of the input sound by multiplying all the sample values by 2. Then rewrite the function so that it takes a second input, which is the amount by which to multiply the sample values. For example, the following calls should be possible with your rewritten function. Increase volume sound, comma 3, increase volume sound, comma 10. All right, so here's the original, and we're going to rewrite it with a second input. All right, so use the same name, def increase volume. It currently has a single input sound. We're going to create a second input. It can be called whatever you want, but I'm going to call it mult because it's our multiplier. Now, we're still going through the whole sound. So this for index in range, 0 to get length of sound, that's still fine. All right, we don't need to change anything there. For index in range, 0 comma get length of sound. We still need to retrieve the sample value. So I'm still doing v equals get sample value at, and then the sound and the index. So this is saying the object that I'm retrieving it from. So I'm retrieving it from the sound that was sent to the function, and I'm getting it based off the index number that's being generated by my loop. Now that I have it, I need to change it. So that's where the set sample value comes in. Set sample value at. Now it's still going to be the sound object. I'm setting it at the same location that I retrieved it, but the value is going to be this, the value that I retrieved, times that parameter that was sent in, so mult. All right? And really, that's the only change. It's just adding the parameter here and changing this to a straight multiplied by 2 to multiply by mult. But otherwise, it's exactly the same. All right? So understanding how to add parameters and then understanding where those parameters would come into play in the actual program. All right, let's take a look at another one here. Examine the function inc volume again. Below that increases the volume of the input sound by multiplying all values by 2. Then rewrite the function so it takes a second input called start index. The rewritten function should multiply the sample values by 2, beginning at the start index and going to the end of the sound. In other words, from sample 0 up to start index -1 will be unchanged, but all samples after that will be multiplied by 2. For example, the following calls should be possible with your rewritten function. All right, so there's the sound that you're sending in, and then there's the starting point. And that starting point might be a straight number, or it might be some sort of calculation like get length divided by 2. All right, but basically the same idea of we're adding adding a second parameter and then understanding where that parameter comes into play in our function here. Where does it actually belong? Okay, so we're still going to do def increase volume. It still needs sound, but now we're going to add a second parameter that I'm going to call start index, right? Because it's going to tell me where I'm starting. Now, when I set up my loop, the original loop started at 0 and went to the end. So this is where our parameter is going to come into play. Instead of starting at 0, we're going to start at our start index parameter. So this 0 gets traded out for start index. We're still going to the end of the sound. That hasn't changed, so we still use get length of sound. And at this point, now that we've changed the loop, everything else is exactly the same. So it's still v equals get sample value at sound, comma, index, and it's still set sample value at sound, comma, index, comma, v times 2. All right, so pretty similar to the problem we just did, adding a parameter, but understanding that this parameter affects, the setup of our loop and nothing down here. So again, being able to look at an existing program and then make that program more flexible by adding parameters and understanding how the code has to be modified to accommodate that. All right, Consider the function below that takes a picture as input. So the function is called changes, and 4p in get pixels. So this is one that's going to run through the entire picture, right? That's why we can just use the 4p in get pixels. And then G is going to equal get green, B is going to equal get blue. And then if G is greater than B, we're going to set blue to 0. All right. So I just want to draw attention to a second. Like on this one, the loop 4p in get pixels, P is actually a pixel. These represent your individual pixels. All right. Which is why I can just say get green of P, get blue of P, set blue of P. All right. On the very first one we did, our loops aren't getting pixels, they're getting coordinates, which is why we had to start with the get pixel command. Right? I think that's sometimes something that trips kids up, is with this, we're getting coordinates, so we have to start with a get pixel. This one, the loop is actually pixels themselves, so we get to skip that get pixel step. All right, so just wanted to make sure we're totally clear on that. All right, but basically what's going to happen is we're going to go through this picture line by line by line, and if the green value is greater than the blue value, we're going to set the blue value to 0. So if we start going through our picture, here green is greater than blue, so blue gets set to 0. Here green is less than blue, so nothing happens. Here green is greater than blue, so it would get set to 0. Here, green and blue are the same. All right. Now, this isn't greater than or equal to. It's just greater than. So that means that nothing would change here. All right. On this next one, green is less than blue, so nothing happens. Green is less than blue, so nothing happens. Green is greater than blue, but blue is already 0. So technically we set it to 0, but it's already 0, so it doesn't really matter. Right? Nothing's really changing. And then on this last one, again, green is greater than blue, so it would go to 0. All right? But we're just going through, and anytime green is greater than blue, we're changing it to 0. And just noticing that when they're equal, we don't actually change it because there's no equal sign there. All right, so being able to look at code, being able to look at one of these and kind of just mark what's actually changing on the picture, what the code is actually kind of doing or executing. All right, so let's take a look at another one of those. So this is a different version of changes. All right, notice this one, as I said before, is using the X, Y setup. So that's why for this one, the first thing we have to do is actually retrieve the pixel, because here our X and our Y's are just coordinates. They're not the pixel itself. All right. Now, why do we do this? We do it because sometimes we don't want to go through the whole picture. On this one, we can see we're only going to the width divided by 2. So again, our width is 4. So this is 4 divided by 2, or 2. So the range is 0, 2, which means we're actually only going to get 0 and 1, because you don't actually ever get up to that last number. But in our y's, we're going from 0 to the height. So the height is 2. So again, this is range 0 to 2, which means for the other ones, we're only going to get 0 and 1 as well. But that's fine, because on this one, the height is only 0 and 1. So we're getting the full height. Basically, we're getting this part of the picture, and we're not looking at this right-hand side at all. Now, what's happening? Well, pretty much the same thing. We're saying get green of P, get blue of P. If green is greater than blue, set blue to 0. So again, here green is greater than blue, so it gets set to 0. Green not greater than blue, we don't do anything. We don't look at these. Green is less than blue, we don't do anything. Green is less than blue, we don't do anything. All right. So this part's pretty much the same, but notice kind of the changes that had to happen. Right here, we used get pixels, so we could skip this get pixel step. All right. In both cases, we did get green, get blue on the pixel itself. But the difference is here, we got the pixel with this line. Here, we got the pixel directly from our for loop. And then everything else was pretty much the same at that point. Only this one went through the whole picture. This one only went through the left half. Okay. So again, being able to take one of these and sort of be able to identify what changes and how those changes work through the picture. All right, number 5. I think the numbering got messed up. Write the function red to blue that changes all mostly red pixels in a pic to blue. Mostly red pixels means within a distance of 140 of red. Hint, use distance, get color, set color. Okay. So we're going to write our function def red to blue. All right. It takes a single parameter. That's a picture. And again, we want to go through the entire picture this time. So I could do a for x in range 0 to get width, for y in range 0 to get height. But since I'm going through the whole picture, why don't I just use for px in get pixels of pic. All right, that saves me the trouble of having to do a get pixel step because this automatically is getting me the individual pixels. Now, because px is a pixel itself, I can just immediately go in and say, all right, if use my distance function, the distance of get color of px, comma, red. So this is going to generate a number. This distance function is going to generate a number that represents the distance between the color of the pixel and red. If that's less than 140, which is what the problem told me to use, then I want to change it to blue. So I can just use set color of px to blue. And again, I can use things like red and blue because they're programmed into our just.py. There's certain colors, some of the core colors that are just automatically coded in here. So I can just say red, blue, and those are sort of built in to our language that we've been using. All right, let's take a look at number 6. It says, write a function to swap the blue and red values of every pixel in an image. So we're going to go through the entire picture. We're going to get all the red values. We're going to get all the blue values, and we're going to flip-flop them. All right. So let's make our function def swap red, blue. It's going to receive a picture as an input. Again, in this case, we're going through the whole picture. So I might as well use for px in get pixels of our pic. And then I'm going to start by getting the red value. So I'll say red val equals get red of px. Now I can't set blue yet because I have to first save the blue value. I don't want to set it because then I'll lose the original value. So I'm going to do blue val equals get blue px. All right. Now that I have those numbers stored in separate variables, now I can actually do my sets and not worry about losing any of those numbers or losing any of those values. So I can say set red of px to the blue val, and I can set blue of px to the red val. All right, and that's just flipping those two values for every pixel in the picture. All right, let's take a look at another one. Python text, exercise 6.34. So that's kind of referring to your book there. Using nested loops, so that means we're not using the for px and get pixels. We're going to go back to x and y. Write a function that reduces red in the top third of a picture and clears blue in the bottom third. All right, so we're going to reduce the red and we're going to clear out the blue. So reduce red, we're just going to say we'll divide it by 2. That's how we'll reduce it. All right, so we'll cut it in half. And then clears blue, we're just going to set to 0. All right, so again, we'll make our function def less red, no blue. And this needs a picture as an input. Now, again, this one we're using nested loops, and we're only reducing the red for the top third. So when we set this up, we can say for x in range 0 to get width of pick. But when we do our y, we only want the top third. So we're going to go for y in range 0 to get height of pick, but we're going to divide that by 3 so that it'll only do the top third of the picture. Now again, because these are coordinates, not actually pixels, my first step is to retrieve the pixel. So I'm going to say px equals get pixel from the pick at coordinates x comma y that are being generated by my loop. Now that I have the pixel, I'm going to change the red value. So I'm going to say set red of px to the old value divided by 2. So I'm going to say the old value, which is get red of px divided by 2. So that's the first part of it. That's reducing the red in the top third of the picture. Now I want to clear blue in the bottom third. All right. So I'm going to set up another nested loop. I'm still using the full width. So for x in range 0 to get width of pick. This time I want to start at the bottom third, or put another way, I want to start 2/3 of the way down. So to start 2/3 of the way down, I'm going to say for y in range. Instead of starting at 0 like I did the first time, I'm going to start at 2 times get height of pick divided by 3. All right, that's starting 2/3 of the way down. And then I'm going to go to get height of pick. All right, so first one, I started at 0 and went to 1/3. Last one, I'm starting at 2/3 and going to the end. And then I'm pretty much doing the same thing. And obviously I'm kind of running out of room right here, but I'm going to do px equals get pixel from pic at x comma y. All right, so I have to retrieve the pixel because these are just coordinates. And then once I've retrieved the pixel, then I want to set the blue of px to 0. So it would just be set blue of px to 0. All right, so the top third, the red is being cut in half. The bottom third, we're setting the blue to 0. All right, but this idea of being able to target different parts of the picture and also kind of understanding what needs to change when you're using nested loops versus the get pixels loop. All right, let's take a look at the next one. Write a function to create a new image. All right, so the fact that it's a new image means we're no longer modifying an existing image. We're actually creating a blank image and then modifying that blank image. All right. So create a new image the same size as a given image. The new image should be a copy of the original, except its bottom half should be all green. The function should return the new image. All right, so this one's going to be a little different because we're no longer just modifying something that was given to us. We're creating something brand new. All right, so let's take a look at this. All right, so we'll call this function, let's go call it bottom green, because we're turning the bottom of the picture green. So bottom green, and it needs a single input, which is the picture that you're actually modifying. Now again, we're creating a new image. So the very first thing we can do is we can create our new image. Now, a lot of times in this class, we've been calling it canvas. So I'll do that. We don't have to call it canvas, but we've been using that. So let's just stick with it. So canvas equals, and then we're going to use make empty picture. And we want it to be the same size as the existing picture. So we'll use get width of pic, comma, get height of pic. All right, so we've now just created an empty picture that's the same exact size as the picture that was sent to us. Now, because we're doing a different thing for the top half and the bottom half, we're going to set up these nested loops again. All right, so for the top half, we're going to start with for x in range, 0 to width, just like we did up above. So for x in range, 0 to, and we can do get width of pic or we can do get width of canvas because they're the same exact size. So it doesn't matter which one we use. And then our y, we only want the top half of the picture for this first part. So for y in range, 0 to get height of pic divided by 2. All right. So again, these are simply coordinates. So the first thing we have to do is we have to retrieve the pixel. So we might say, original px. So I'm going to say original px equals get pixel from pic at coordinates x comma y. All right. Then I want to know what color is at that pixel, because if I'm going to copy it, I need to know the color at that pixel. So I'm going to say original color equals get color of original px. All right? So I now know the color of the original picture. I have to write that color, or I have to set that same color on our blank picture. All right, so what I first have to do is retrieve the pixel of our blank picture, because right now this is the pixel of the original picture. So I'm going to call this one new px, and I'm going to do a get pixel from our pic. Oh, sorry, not from pic. Pic's where you got it from our canvas at the same exact coordinates. So now I have my original pixel, I have my original color, I have my new pixel. And now this new pixel, I'm going to set it to the original color. All right, so I'm going to say set color of new px to the original color. And that takes the original color and copies it over into our new empty canvas. All right, so that's the first part. That's the part that just goes through, copies the old picture into the new picture, and makes, keeps it the same exact thing. Now the bottom half of the picture, we just want to be green. All right, so now we've got to do the bottom half of the picture. So we're going to set up a new set of loops, and we're going to say for x in range 0, comma, get width of pic. And then we're going to do our y, and instead of starting at 0, we're going to start halfway down. So for y in range, get height of pic divided by 2, and we're going to go to get height of pic. All right, so there's my loop that's going to go through the bottom half of the picture. Now on this one, I don't really even need to look at the original pic. I just need to set my new one to green. All right. So I can just say new pics equals get pixel from the canvas at x, comma, y. Now, obviously, I'm about to run out of room, but I'm just going to go up here. Now that I've retrieved the pixel, I can set the color. So I can say set color of px to green. All right, so I retrieve the pixel from the canvas, then I set the color to green. And then the very last thing, it says this one should return the new image. So my last line, and I'm just going to note that this should be not in the loops, because I can't really show that because I had to use my arrow. I can just say return canvas. All right. So again, the top half is a little more complicated. It has to retrieve the pixel from the original picture, get its color, retrieve the pixel from the canvas, and then set the color appropriately. The second one's a little easier. We just have to retrieve the pixel from the canvas, set it to green. And then when the whole thing is done, when both loops have finished, then we can just return the canvas. Okay? So let's continue on. All right. Python text, exercise 812. Write a function to add 1 second of silence to the beginning of a sound. It should take the sound as an input, create a new empty target sound, then copy the original sound starting after the first second in the target. The function should return the new sound. All right, so this is another one where we're going to be returning a value We're not simply modifying what they give us. So let's make our function def add silence. All right, and the only thing this needs at the start is a sound. All right. Much like the picture that we just made, we're going to start by making an empty sound. So we'll call it target. So target equals make empty sound. All right. Now, when we make an empty sound, it's by default silent. All right. All the values are 0. So we just have to make sure that this is the appropriate size. So we're going to say get length of the original sound they sent us. And then we're going to kind of work on the assumption that everything is that same sampling rate that we used all course long. So our sampling rate's 22,050. So we're just going to add 22,050 to that length, which is going to give us an empty sound that's the length of the original sound plus 1 extra second. All right, so we've just basically added an extra second to our sound. All right. Now we've got to set up a loop that's going to copy the existing sound into our empty sound, but leave that first second blank. Leave that extra second that we've created blank. All right, so we're going to make a loop, and we're going to say for x in range from 0 to get length of sound. All right. We're going to retrieve the value from our sound because we need to know the value if we're going to copy it over. All right, so we'll say value equals get sample value at. All right, and we're going to use our sound, and we're going to use x. So far, all we've done is retrieved the values from our sound. And then this is the part that's a little trickier, but we're going to set sample value at. We're going to be setting the target because that's our new sound that we're making. And we can't just set it at x because then that's going to fill in the beginning of the sound. We want it to leave that first second blank. So what we're going to use is we're going to do x plus 22,050. All right, so that's going to leave that first second blank and then just go up as our loop goes up. And we're going to set it to the value that we just retrieved. All right, so that'll leave the first second blank and then copy everything else after that. All right, and we're just using that offset so that we get to keep our first second completely empty. And then when we're done, we can just return target because, again, this one is supposed to return a sound. All right, so pretty straightforward. This, you just have to know your sampling rates. This is what we use pretty much all year long. So that's how we're adding a second is the 22,050. And then this idea of kind of using this offset so that we leave the first second blank when we're filling in our new sound. All right, only 2 more to go. Let's see what we got here. So write a function to take a sound and produce a new sound that is a copy of the original sound, except that every other sample value should be 0. For example, if the original sound has a sample value 54, negative 76, 13, 99, then the new sound should have sample value 0, negative 76, 0, 99. The function should return the new sound. All right, so there's 2 ways to think about this. One is every other sound is 0. The other way to think about this is the even indexes are 0. The odd indexes are whatever they were. So even indexes are 0. odd indexes are a copy from the original file. All right, so we can use this idea of even odd to sort of flip back and forth between the two of them. So let's call this def every other 0. All right, and again, it takes a sound as an input. So sound as an input. It wants us to create a new sound. So the very first thing we're going to do is make our blank one. So target equals make empty sound. And this one's going to be the same exact length, so we don't have to do any addition this time. We can just say get length of sound. So now we have a blank sound. It's the exact same length as the one that was sent in. All right. We're going to set up a loop, just like we did up above. So for x in range 0 to get length of sound. All right, we're still going to retrieve the value from the original sound that was sent to the function. So value equals get sample value at sound, comma, x. Now, this is the part where it changes because depending on whether it's an even or an odd, we either just copy the value over or we set it to 0. So we're going to need an if statement so that we rotate back and forth, and we can say if x percent sign 2, all right, this is our modulus operator. This is what tells us the remainder. So if the remainder, when we divide by 2, equals 0, we know that it's an even index, all right? And we just saw that the even indexes get set to 0. So we can set sample value at, and again, we're setting the sample value of target now, not sound. We're setting target at location x to the value 0. Else, all right, and I apologize, this if statement should actually be indented in. It should be indented in underneath the value there. So all of this should be indented in. I'm sorry. I don't know why I indented back out there. That's my bad. But both of these should be indented because they're part of the loop. They're happening inside the loop. So those should both be indented. Else, we're not setting it to 0. We're setting it to that value we just retrieved. So we're copying the value from the original sound. So set sample value at, we're still setting the target. We're still using the location x, but we're copying the value from the previous sound instead of just setting it to 0. All right. So if it's even, we set it to 0. If it's not even, we use the value from the original sound that was sent to the function. And then when we're done, we just return target. All right. And that one should not be indented because we don't want to return until after the loop has finished. So these should both be inside the loop. This should be outside the loop. All right. But basically, again, we make an empty sound. We set up a loop that goes through the original sound. We retrieve the original values. If the index, because x is our index, if the index is even, then we're setting it to 0. Otherwise, the index is odd, and we're using the original value from the original sound. Okay. So that brings us to a final question. SpongeBob. It's pretty great. Complete the Python function prettyFrame below that takes as input 2 images, frame and pic, both the same height and width. The pixels in the frame image are either white or black. the function should modify the frame image so that each white pixel is changed to the color of the pixel in the same location of the other image pic. For example, suppose the image frame is shown on the left and the image of SpongeBob is shown on the right. After running the function with these two images, you would get the resulting picture. All right, so we're basically taking these two and then we're modifying this file. All right, we're not creating a new file, we're modifying the file that they gave us. All right, so pretty frame, frame pic. Now, because we're dealing with two pictures, it's usually easier to set up the XY than get pixels. So I'm going to do for X in range 0, comma, get width. Doesn't matter which one I use because they tell us that they are the same size. All right, so because they both have the same height and width, it doesn't matter which one we use. So I'm just going to use frame. And then I'm going to do the same for our Y here, for Y in range 0 to get height of frame. Right. Now remember, this is only giving me coordinates, so now I need to retrieve the pixels. So I'm going to say frame pixel equals get pixel from the frame at location X, comma, Y. And I'm going to say pick pixel equals get pixel from the pick at, again, locations X, comma, Y. So now I've retrieved the pixels from both of these. What I need to check now is whether or not this pixel is white. All right, so I've got to check to see whether that pixel that I just retrieved is white. So I could say frame color equals get color of frame pixel. All right. I now have stored the color of this pixel in my variable here. Now, normally we'd have to use a distance function to make sure, like, is it close to white? But this tells us that the frame is either straight black or straight white. So because it's telling us it's straight black or straight white, we can just say, hey, if frame color equals white. All right. In a normal picture, they might not all be 255, 255, 255. And we'd probably want to use like the distance function here and see, are you really close to white? But in this one, since they said it's either 0, 0, 0 or 255, 255, 255, we can just say if frame color equals white. And if it does, that means that we want to take this one and copy it over to this one. So if frame color equals white, then we're going to want to know the pick color. So then we can say pick color equals get color from our pick pixel. And now that we know the color of our picture, we can use that to change the color of our frame. So we're going to set the color of our frame pixel to our picture color. All right. And that'll do it. That'll frame this picture inside of this other one. All right. So let's again just review what we did. All right. We set up a loop for X and Y that was going to go through both pictures entirely. We retrieve a pixel from the frame. We retrieve the pixel from the picture. We then retrieve the color of that pixel. And we say, hey, is the color white? All right, because if the color is black, we don't have to do anything. All right, but if the color is white, then we want to know the color of this picture. And then we use the color from this picture to change our frame and fill it in. All right. And this would take this picture and only fill in sort of the white circle there with whatever needed to be there. So again, this is an example of like a more involved sort of, picture program that you might have to write on a final exam. All right. But this is what you need to be able to do on the Python front. All right. There's all sorts of sound and picture questions that could be asked. There could be ones where you're writing programs. They could be ones where you're showing me what's modified, and it could be showing me what's modified in a picture. It could be showing me what's modified in a sound. But basically being able to read code, being able to write code, understanding where and how to use parameters is something that will definitely pop up. So this is, again, all the stuff that you need to know to be successful on the coding part of our final exam. All right. So again, hope this was useful. Obviously, if you have any questions, just let me know and we'll go from there. All right. Have a great day.